If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, find the radius of convergence and the interval of convergence of the series. And it's the sum from n equals 1 to infinity of 3x minus 2 to the n all over n times 3 to the n. Smash that like button and let's get started. We want to find for which values of x does the sum from n equals 1 to infinity of 3x minus 2 to the n over n times 3 to the n converge. And so the way we do this is we use the ratio test. So we do the limit as n goes to infinity of the n plus first term in our sum over the nth term. And when we work this out, we get the limit as n goes to infinity of, well, the n plus first term is 3x minus 2 to the n plus 1 over n plus 1 times 3 to the n plus 1. And dividing by the nth term, we get n times 3 to the n all over 3x minus 2 to the n. Now notice we have a 3 to the n in the numerator, 3 to the n plus 1 in the denominator, similarly with the 3 to the x minus 2 terms, so most of the terms cancel out, and we're left with the limit as n goes to infinity. Well, n is a positive number here, so we could factor it out without the absolute value. So it's n over n plus 1 times the absolute value of 3x minus 2 over 3. Well, the limit as n goes to infinity of n over n plus 1 is just 1, so we're just left with the absolute value of 3x minus 2 over 3. And we want this absolute value to be less than 1. Another way to write that is negative 1 is less than that term, which is less than 1. Multiplying each part of the inequality by 3, we get this, and we're going to continue to simplify until we get x by itself. This will give us our interval of convergence without the endpoints. We'll still have to test the endpoints. So we know that our power series converges when x is between negative 1/3 and 5/3. So the last thing we have to do is check the endpoints. So when x equals negative 1/3, our series is the sum from n equals 1 to infinity. Well, let's just replace every x with negative 1/3, and we'll simplify it. And now we're going to have a question that we may have done, last week or so. We'll have to use certain tests to figure out if this converges or diverges. So this simplifies to the sum from n equals 1 to infinity of negative 3 to the n over n times 3 to the n. Well, those 3 to the n's cancel. So we have the sum from n equals 1 to infinity of negative 1 to the n over n. This converges by the alternating series test, right? The terms alternate, and then the limit of the terms goes to 0. So we know it's convergent. Let's do the same thing with x equals 5/3. When we sub in x equals 5/3, we have 3 times 5/3 minus 2 to the n over n times 3 to the n. Well, that numerator, when we work it out, is just 3 to the n. So our sum has a 3 to the n over n times 3 to the n. The 3 to the n's cancel, and we're left with the sum from n equals 1 to infinity of 1 over n. And this diverges. This is the harmonic series. So our interval of convergence is negative 1/3 included to 5/3 not included. And for the radius of convergence, you find the length of the interval, which would be 5/3 minus negative 1/3, and then cut it in half. So that's 2 over 2, which is 1. So our radius of convergence is 1. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.